Welcome to the video for College Algebra, Section 8.1 on Systems of Inequalities. This will be our last chapter for this class, so let's get started. Section 8.1, we are going to solve linear inequalities in two variables, graph the solution regions in two variables, and solve systems of nonlinear inequalities, that's a typo, in two variables. So to start out with, we're going to be graphing inequalities pretty much. So just keep in mind that an inequality has a multitude of solutions, not just one that we can just name. So oftentimes the solution will be a whole region of a graph, a whole part that you shaded. So if there's only one inequality, then we'll shade like a whole half plane. If there's more than one, it might make a bounded region, so we can actually like make rectangles and quadrilaterals that are shaded in by different graphs. So in order to graph an inequality, the first thing you need to do is graph its border and then decide which side to shade. So it's just like graphing a normal line, but then we have to decide if it's solid or dashed, shade it. When we have more than one, where they intersect are called corners, and the solution is that shaded area that we talk about. So if we just have one inequality, we just need to graph. So first of all, if I was going to graph this line, I personally would put it in slope-intercept form so that I can more easily graph it. I'm actually going to ignore that inequality sign for right now and just treat it like an equal sign. I am subtracting 6x over to the other side and rearranging it. Then we're going to divide by -3 and rearrange it some more. So the equation of the boundary line, if I divide these, I get -5, and if I divide these, I get +2. So this equation rearranged is y equals 2x minus 5. I need to graph the boundary line. Start at -5, slope is 2. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1. Okay, now before I actually draw it, I need to decide if that's going to be a solid line or a dashed line. So if this has the equal sign in it, you're going to be solid because it equals it. So we need it. If there is no equal to sign, you're going to do a dashed line instead. So in this case, it's equal to. We're going to draw the solid line that goes through those dots the best that you can with the tools that you have. Okay, and then the last step is to shade. So in order to shade this graph, we need to test some points. You can, because either the solution is on this bottom right half or it's on the top left half. And once I know one point, I know that all of these would be true because I'm either on one side or the other of the line, as long as your line is graphed correctly. So in order to do that, we can pick a test point. My favorite test point is to pick 0, 0. So x is 0 and y is 0, and you put it into the equation. And so if we plug in a 0 in here, we get 0 minus 0 is less than or equal to 15, which is true. So 0, 0 is a solution to this graph. That means everything on this side is a solution. So I could color it in. I'm going to try to use the highlighter because it will be prettier. So color in this side of the graph. Everything over here on this side would be a solution to this inequality. So that's the answer. That's what I'm looking for. Just to clarify that testing step, if you wanted to, you could always test another point. For example, let's pick a point over here on this side, like 5, 0. So I could test 5, 0. I put 0 in, or x, sorry, 5 in for x. That would be 30. I put 0 in for y. That would be 0. And this says 30 is less than 15, which is false. So I know that 5 is not a solution. So if I had picked a point on this side, I would know that that's not a solution. So that means I need to color on the other side. Anyway, that's how you graph a linear inequality. Now the rest of this lesson, we're basically going to do a system of inequalities, which means we're doing 2 or more at the same time. And then those will make like a region of solutions. So here we have an application. A rental agency has a maximum of 1.26 million to invest in the purchase of at most 71 new cars of 2 different types, compact and midsize. The cost per compact car is $15,000 and the cost per midsize car is $28,000. The number of cars of each type is limited by the budget available and the number of cars needed. So we have some constraints. These constraints are where we get our inequalities. We can buy at most 71 new cars. So there's a limit there. Maybe that's all we have room to park. Because these inequalities deal with 2 types of cars, they will keep 2 variables. We have compact and mid-size. So X is compact and Y is mid-size. So let's write some equations that would be applicable here. First of all, we know that we can have at most 71 cars. So X plus Y, the total of the 2 different kinds of cars that I buy, has to stay below 71. Also, we can't buy negative cars. So for this real world application, the number of cars, compact cars, and Y and mid-sized cars must remain greater than or equal to 0. So I've got 3 inequalities here now, 3 different graphs that I could do all at the same time. So first of all, let's start with the X is greater than 0 and Y is greater than 0. In order to graph those, we would keep an XY plane here. And they need to be in the first quadrant because we're not going to be negative. So those are basically boundary lines right now. And the other graph is X plus Y equals 71. I could rearrange that by subtracting X over to this side. So it starts at 71 on this side and it goes the slope of -1, which means that it crosses at 71 on this side. Now, what are my units? What is X and Y? X was compact, I think, cars, and Y is mid-size cars. So basically, it's how many cars of each could I buy? I could buy all 71, be compact, and no mid-size, or I could buy 71 mid-size and no compact. What about shading? Well, don't forget to shade. So this one's pretty simple. I can't buy more than 71, so I can't be over here. I have to be in this area. So when you go to shade, if your tools work, you would color in this region here. So this is how you get a bounded region with some corners on it. And we'll talk about that a little bit more in a minute. There was another restriction on this, and that is that the maximum amount of money we want to spend. So we only want to spend 1.26 million. Now they're going to tell me that compact cars are 15,000 and midsize are 28,000. So we need to write an equation for that. Well, I'm buying 15,000 times X compact cars down here, 28,000 times Y mid-sized cars, and I have at most 1.26 million to spend. So here's my new equation. Now we're going to add that to the same graph, but I have it over here. So if we wanted to graph this equation, you'd have to do a little bit of working to get Y by itself and graph it. But anyway, you can use your calculator also. This is what it looks like. So this is how much money I can spend. I can buy 45 mid-sized cars, and that would equal that much money. So then I wouldn't have any money left to buy any more compact cars. Or I can buy 82, I'm not sure what, 83 maybe, compact cars and no mid-size. Or I can buy any of these combinations. I could buy 10 of each, and I would definitely stay under that restriction. But I might want to, have more cars than that, especially if I'm trying to sell them. So basically we have these 3 different equations. This is the money equation, just simplified down. And it's 4 equations, not 3. And then we have the quantity. We want to have less than 71 total cars, and we have to stay positive. So if we put all 4 of these on the same graph, we get this. When you shade, the money one was shaded below, and the quantity one was shaded below. So where they're double shaded makes this 4-sided quadrilateral here. That is our solution region. I can't buy 71 mid-sized cars because I don't have enough money for that. So I can do that. I can't buy 83 compact cars because I can only buy 71 cars. So I'm stuck in this region right here. And on these kind of problems, they're going to ask you to find those corners. So you find the coordinates of all the corners. Most of them are going to be pretty easy. This one's 71, 0, 0. I believe this one's 0, 45. And this one, in order to solve this, you would have to set these two equations equal to each other and solve them. And I believe that's what we're looking for here. So we're going to take those first two equations and solve them. I'll just do it on this page. So we have 71 minus x equals 1260 minus 15x over 28. So we need to solve that equation. Let's multiply by 28 onto the other side. 71 times 28 is 1988 minus 28x equals 1260 minus 15x. We're just doing some algebra here and solving this. Negative 15x plus 28x is 13x. And I'm going to subtract the 1260 over to the other side. 1988 minus 1260 is 728. And then we divide by 13. X equals 56. So this point right here is 56 comma. And I need to find out the y value, so I can go back to my original equation and do 71 minus 56. So I can buy 15 y cars. So this little point right here is kind of an optimal point. If I bought 45, that's the point, 0, 45. So if I bought 0 of one kind, 45 of the other, that's okay, but am I going to make the most money? I don't know. So then what you would do is take these points that we have, 70, 0, 0, 45, 0, 0, and my intersection point, and we would plug them into something called a profit function. So there will be some problems that give you another formula. The only thing you do with that formula is you plug in all four of these numbers, and if you want to make the most profit, you pick the biggest answer. Most of the time it will be this one, but sometimes it can be these other points that are on the axis. Maybe I will make a lot more money on compacts. It depends on which one you can sell for more money. So that basically solves this problem. You can also solve a system of inequalities. Basically, you're just graphing two at the same time. So in order to do that, it's just like the first problem we did. I'm just going to show it to you because I don't have the answer. Let me show it to you. It's over here. This one would look like this. Basically, you get two lines, and one of them's solid because this has an equal to on it. This will be a solid line, and this one's dashed. So that's what it would look like. And then when you pick a point, you can pick a point in each quadrant and test it, or you can just take the first graph and pick a point and decide if it's above or below, and then pick a point for the second line and decide if it's above or below. All right, one more part to this lesson is solving nonlinear systems. So sometimes we are going to have some curves and things going on. So this is one example, and then I'm going to do one or maybe two with you. So here's a parabola that opens downward. We can tell by looking here, and this one's a line. And so when you graph that, you might get a curvy section. So let's try one of those. All right, so for our first example of nonlinear inequalities, we have a quadratic here and a quadratic here. These are not solved for y, so you can graph this in many different ways. You can make a table of values. You can factor and find the zeros. You can use the formula for vertex. You can also use your calculators. So let's start with rewriting each equation so that y is alone. So what I'm going to do is leave the y here on the left and then move these terms over. So like I'm going to subtract x squared over to the right. I'm going to add 10x over to the right side. So there's my new equation for the first one. The second one, I'm going to leave the y on the left side, greater than or equal to, and I'm going to add x squared, subtract 8x, and then the 28 is going to stay there. So there's the functions that we need to graph. So like I said, you can make a table of values. I can tell that this one's going to go through 0 and 10 because those are numbers that would give it a 0 value. So if you put that in your calculator, then you need to decide solid or dashed. They're both solid, so that's pretty easy. The third thing you need to do is test a value. So I'm going to show you what they would look like. This is actually the answer. You have to change your scale a little bit so you can see up this high, but this is what they look like. So we have our negative x squared plus 10 is this blue one, and x squared minus 8x plus 28 is the red. And then how do I know that it was shaded in between? It is possible that it's not that section. Usually it is, but it could have been up here or down here or over here or over here. There's like 5 spots it could be. So we always want to do that test value. And so just to show that one more time, I'll show you what I would do to test. So since we're going to guess that it probably is in here, you're going to pick a point like 515 is definitely in this section. So pick your point 515 and then you plug them in to both equations and see if they're true or false. So we can do one at a time. If we put it in the the blue equation, the top equation, put a 5 in there, you get 5 squared minus 10 times 5 plus the y coordinate, which is 15. That value is negative 10. I got negative 10 is less than or equal to 0, which is true. So for the blue graph, I now know that I'm below it. So somewhere down here is the solution. It's definitely not out here. I could also plug it into the second equation where I would get negative 5 squared plus 8 times 5 plus 15. And in that equation, I get 30 greater than or equal to 28, which is also true. So for the red graph, I need to be above it. And in order to be below the blue and above the red, I have to be in this section right here. So that is the finished answer. There's no way to answer this question in words. The answer is a region of the graph. It's all of this space here. So make sure that you color in. Make sure I can tell if it's solid or dashed. If you accidentally make it solid, you can write a little note that says it's dashed, but make sure that is clearly available to tell. All right, now we have one. This one's a little more basic. We need to graph the system. There are 4 different equations here. So let me just get a graph and we'll do it on here. So x is greater than x cubed minus 3x. So we need to look at that graph. If you want to, you can put them in your calculator. X to the third minus 3x, graph that thing just on a normal scale. We could get some nice points here. We know it goes through 0, 0, goes through 1, negative 2, 2 is up at positive 2, and then 3 is 18, so it's doing a little wiggle there. And negative 1 is positive 2, and negative 2 is negative 2. So pretty much it's going up, down, up. Not perfect, but that's what the first graph looks like. Second graph, y is less than x. Well, the line y equals x goes across. Oh, I forgot to make that one dashed. You guys gotta catch me on that. So I have this lovely eraser tool that I get to use to make mine a dashed line. So use pencil or whiteout or an eraser. There we go. Now we have a dashed line. So the second line is y equals x, but it also should be dashed. So I'm going to start at 0, 0 and go up 1 over 1. Make my dashed line there. Let's pick another color. Y is great. X is greater than negative 2.5. So on the x-axis, I find negative 2.5. And if it's x equals, it's a vertical line. So I'm just going to do both of these in blue. X is less than 2.5 is here. So here is my crazy drawing. So you can see that there's a lot of different sections that could be shaded. Get my little pointer tool, show you. So there is well, all this over here, over here, over here. There's this little loopy spot here, here. There's also a little sliver right here between the purple and the blue, but below the red, and above right here, there's like a little triangle here also. So now we need to decide where to shade. we can test values. Let's do test values, and we'll just test one at a time and see where we are at. So we can't use 0, 0 because it goes through 0, 0 for these first two. We can use for these two, but they also just tell us x is greater than negative 2.5 and less than 2.5. So I know that I'm somewhere between these two blue lines. So now I just need to do the purple and the red. So for the purple one, let's pick a point like for purple, how about 1, 1, 1, 1. Ignore the red line, and we're just talking about the purple line. If I choose 1, 1, I'm above it. I could do any other point, but 1, 1 sounds easy mathematically. So if I plug in a 1 for y, I have a big pin now. Hold on. Test 1, 1. And I'm doing this on the purple graph. I would get 1 is greater than 1. 1 to the third is 1 minus 3. 1 is greater than negative 2 is true. So purple is above. Okay, purple is above. And then let's do the red one, which is y equals x. I can't use 0, 0. I can't use 1, 1. Let's test above on that one too. So test 0, 1. Be very careful that you put the x in the x, the y in the y, and that you name your point correctly. We're talking about this 0, 1 up here, not 1, 0. The x is 0 and the y is 1. Is 1 less than 0? No. So that's false. We are not above. We're below the red line. So we need to be above purple and below red. Where does that happen? Here's one spot, above purple and below red. However, there's another one. It's just tiny. We are above purple. It's like this little triangle here that, there we go. So those two black parts are the two regions. And to graphically solve it, you have to no words, you have to draw it. And I believe that concludes this lesson on solving systems of inequalities. So make sure you show your work. I will post some graph paper that you can print out. You're also welcome to draw your own, or you can always get one of those special little stamps. Anyway, if you have any questions, let me know. Take care.